Hello and welcome to So This Is How We Do It. We're going to explain how to do these problems that many of you struggled with. So, first, the whole first section are ones without a calculator. Problems that after working with these numbers for 2 weeks, you should be very, very comfortable in dealing with. I think it's always easiest to deal with the bottom number first, the root first, because then you end up with smaller numbers. Remember, this means square root of 4 to the third, which is square root of 4 is 2, and 2 to the third is 8. You might want to pause the video and copy down the problems first. That might help you if I go too fast, because I'm going to fly through these now. This is fourth root of 16. Don't leave it like this, because the directions say to evaluate, which means to give a value, which is a number. This is not a number. This has a radical in it. So we want to know what number is that. How many dollars is the fourth root of 16? Well, 2 times 2 times 2 times 2 is 16. So the answer is 2. 27 to the 1/3. That is the cube root of 27, which is 3. This is cube root of 8, then squared. Cube root of 8 is 2, and 2 squared is 4. This is square root of 9 to the third. Square root of 9 is 3. 3 to the third is 27. 16 to the 1/2 is square root of 16, which is 4. 36 to the 1/2, that is square root of 36, which is 6. 81 to the 3/4 power means the fourth root of 81 to the third. Fourth root of 81 is 3, and 3 to the third is 27. 125 to the 2/3 means the cube root of 125 squared. Cube root of 125 is 5, and 5 squared is 25. You should be able to do all of these pretty fast. Now, from your notes, how can you write this in 2 different ways using radicals? X to the a over b power. The bottom number is the root, so the b root of x, you could write it to the a, or we could write it the b root of x with parentheses to the a. Almost all of the problems in this section, I used this formula, the second one, where I did the root first and then I did the exponent. The next section says write using exponents. So I'm giving you problems with a radical, this is a radical, and I want you to rewrite it using exponents. And then simplify if we can. Here the 2 is not part of this at all, so the 2 can just be 2 to the first, but it's x to the what power? Remember, there's no index written here, so the index is always 2. This number is the numerator. This number is our denominator, so it's 2x to the 3/2 power. On this one, we have a 2, but now it's not to the first like it was here. Now it's on the inside of a radical. Square root, remember the exponent here is a 1, and the index is a 2, so it's the 1/2 power, and then x to the 3/2 power. Now I've just written them using exponents. This is y to the numerator is 5, denominator is 4, 5/4 power. Down here, x to the 2/2 power and y to the 5/2 power. Now this one can actually be simplified because we know what 2/2 is. 2 divided by 2 is just 1. So the answer is x to the first. We could write 1 and we don't have to. Y to the 5/2. This one we have x here, and this one is x to the 2/2 power. Oh, wait a second. We know that's x to the first. So what's x times x? X squared. Here, this is y times y to the 1/2. Okay, I need to smush them together. I don't want to leave them like that. I need a common denominator. I can change 1 into 2/2. And then when you're multiplying common bases, add the exponents. 2 plus 1 is 3. Denominator stays 2, so it's y to the 3 over 2 power when you put those together. So this was all starting with a radical, writing answers with exponents. The next section is reversed. We start with an exponent and write with a radical. X to the 2/5 power, that is just the 5th root of x squared. Or I could do parentheses and put the squared on the outside. That would be fine too. Now my answer has a radical. That's all I'm trying to do. This one, the whole thing is under the square root because the 1/2 power is the same as square root. But this one can be simplified because I know the square root of 4. That is plane 2. So I'm going to make this plane 2 and then still square root of x. Here, this is the 5th root of a squared b, and that's done. This one, the common mistake is that people will put a in the denominator when they see the negative 1/2 power. But the x is the only thing to the power. A is just friends with them. So a is going to stay in the top. The x is going to have to go downstairs because it's negative, and I change it to positive when it goes downstairs. And then I know to write it as a radical, I got to change the exponent to a square root. Here, this one, the 9 is part of the exponent. So this negative is over this whole thing. So the whole thing has to go downstairs. But this can be simplified because I should recognize that 9 is a special number. I know the square root of 9, that is 3, so we'll go plane 3 times radical x. Okay, the last one, x to the 3 over 2 power. This means the square root of x to the 3rd. But then I give that hint to simplify, because we can make this smaller. We know this means there are 3 x's. 2 of them make a plane x. So that means that we have 1 plane x with 1 here in the radical left over. The best answer here is x radical x. Simplify each radical expression. So when it says simplify each radical, what that means is make the part in the radicand as small as we possibly can. Write this number. This is 125. Can we make it a smaller number? Here with the x's, I have 5 of them. I know that every pair of square roots makes a plane number. So there's a plane x, here's a plane x, here's a leftover in the radical. So it's x squared radical x. Here we have 12. So this can be broken down to be 4 and 3, 2 and 2. Radicals on all of these. I have a pair of squares. I have a plane 2 here. I have a plane 5 up here. And I've got 1 radical 3 left over. So it's plane 10 times radical 3. And you notice how I started with a 12 and now I've got a 3. I've made it smaller. It is now simplified. 81. 9 and 9. 3 and 3. Here's the slow way to do it. I can do a pair of squares and get 3. Do a pair of squares and get 3. 3 times 3 is not 6. It's 9, by the way. And here's my 6. So 6 times 3 is 9. Or 6 times 3 is 18. And 18 times 3 equals 54. That's the slow way to do it. You could recognize, wait a second, I know the square root of 81. That is 9. This is just the same as 6 times 9, which is 54. We could have done it that way too. So this is how you do it. All right, 125. 5 and 25. That's a perfect square. I know that's going to be plane 5 because we've got a pair of squares coming from it. So this is plane 5 here. Radical 5 underneath. Now I have to do the x's. We have 3 of them. These 2 make a plane. This one is left over. It's under the radical. So it's 5x times radical 5x. 80 becomes, we could go 10 and 8, 5 and 2, 4 and 2, 2 and 2. We have a pair of squares here. We have a pair of squares here. So we've got plane 2 times plane 2. This guy's left over. Radical 5. Now the p's. We have 4. That makes 1. That makes another. So it's p times p, which is p squared. So my answer is 4p squared radical 5. Number 6. Square root of 64, I know that. That's 8. That's the best way. Now we've got 3. That makes 1 with 1 left over. I've got 3. That makes 1 with 1 left over. 75, 3, 25, 5, 5. Here's my pair of squares. This is left over. 5 left over. X squared, there's 2 of them. That makes a plane. There's only one y. No friends. He's underneath. 200, 102, and I know 100. Isn't that 10? So this is plane 10, radical 2. There's the fast way. 48, 8, 6, 4, 2, 2, 2, 2, 3. I've got some pairs of squares. Here's a plane 2 and a plane 2. And I've got a plane 3. And I've got a radical 3. 2 times 2 is 4. 4 times 3 is 12. So we have 4 radical 3. This is how we do it. Do it.